Welcome to Section 8 of Chapter 3, the HL Postulate. In this section, we're going to use the HL Postulate to prove right triangles congruent. So far, we have three postulates to prove triangles congruent. That's side, 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 and angle, side, angle. Okay, today we're going to look at one more postulate that works for specifically right triangles. Okay, so the postulate states if there exists a correspondence between the vertices of two right triangles such that the hypotenuse and the leg of one triangle are congruent to the corresponding parts of the other triangle, the triangles are congruent. So what that means, we have two right triangles. So we first off have to know that this is a right triangle and this is a right triangle. Whether we state it by saying that we have a right angle and then state that it's a right triangle, or we're told that these two triangles are right triangles. If we have the hypotenuse, remember the hypotenuse is the longest side of the triangle, or the side opposite the 90-degree angle. So if the hypotenuse is congruent to the hypotenuse over here, and we just have one other leg, doesn't matter, any leg, so this leg is congruent to this leg, then the two triangles are congruent. Okay, we don't need to have the side angle side, or side side side, or angle side angle like before. With right triangles, we can use this HL postulate as a shortcut. Because notice we only have two sides. Now we could state that these angles are congruent, but we don't need to. We just need to know they're right triangles. So by just having two sides, the correct two sides of a right triangle, we can prove the triangle's congruent. Okay, now let's review that real quick. Remember, it needs to be the hypotenuse and one leg of a triangle, of a right triangle, is congruent to the hypotenuse and the same corresponding leg to another right triangle. Okay, so let's take a look at this. I want you to copy down the given, copy down what we're trying to prove, and copy down this diagram. Take a second. Think about what we have and think about what we can state, what we can conclude from our given. Okay, so let's start here. So let's look at what we can state and what we can conclude from this information. So first off, let's go ahead and state our given that BC is perpendicular to AC. Okay, what does that tell us? Well, if BC is perpendicular to AC, that tells us that this angle right here is a 90-degree angle. Okay, or more importantly, it's a right angle. So let's go ahead and state that. Let's state that angle C is a right angle. And why can we state that? Well, if perpendicular, then right. Okay, so next, let's talk about BD is perpendicular to AD. Well, if that's the case, then this is also a right angle. So BD is perpendicular to AD because it's given. And then angle D is a right angle. And that is the same as 2. Okay, so we have two different right angles. And I know you might be thinking to a homework problem you had a few days ago where you had to prove that a triangle was a right triangle. And so in that proof, we needed to state that the triangle was a right triangle because that in itself was the conclusion that we were trying to prove. However, in this, we do not need to state that triangles ABC and triangle ABD are right triangles. Because we've already stated that they're right angles, it's implied that they are right triangles. So we do not need to state right triangles here. So we can go right into trying to find a hypotenuse and a leg that are congruent. So let's take a look. Well, AB is congruent to AB because it's reflexive. And what piece of each of the triangles is AB? Well, if you look, it is the hypotenuse of both triangles. It's opposite the 90-degree angle in ABC. It's opposite the 90-degree angle in ABD. So it's the hypotenuse of both triangles. So we have just proven that our hypotenusae are congruent. Now we need to get a leg. Well, let's use our last piece of given information, that AC is congruent to AD. And that gives us our leg. So we can now state that these two triangles are congruent. So triangle ABC is congruent to triangle ABD. And why can we say that this is true? Well, because of our HL postulate. So just like SAS and SSS and ASA, we write in HL in steps 5 and 6. Okay, so we have our triangles congruent, but remember, we're trying to prove that AB bisects CAD. So in order for AB to bisect this big angle here, we need to state that this angle is congruent to this angle. Okay, and I'm going to cheat in here and call this angle 1 and angle 2. Okay, and that's just for simplicity's sake. We'll say angle 1 is congruent to angle 2. Why is that the case? Well, we have two triangles congruent. They're corresponding angles, so CPCTC. And then we can wrap this up by saying, well, if those two angles are congruent, then AB must bisect angle CAD. And we can say that because if two congruent angles, then bisector. Alright, so there you go. 9-step proof using the HL postulate to prove two right triangles are congruent. Remember, this only works for right triangles. Okay? If we don't have right triangles, well, then we got to use the normal side, 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 angle, side, angle, side, angle. Okay, I want to help you out with a couple homework problems here. I just want to talk through a few things and how you're going to set some of these up. So on page 158 is going to be the start of your homework, and we're going to talk about number 3 here. Now, I know my drawing isn't perfect. It looks similar to what you see on page 3, but my angles are a little off, and I'll explain. So we're given that O is the center of the circle, and we're given that YO is perpendicular to Y-axis. So this angle right here is a right angle, and this angle right here is also a right angle. So you're going to state that we have right angles just like we did in the example on the last slide. And one thing that's going to help you here, though, is to draw OX. So make sure in your proof you state that you draw OX. And remember, why can we do that? Well, we can do that because it's an auxiliary segment, and 2 points define a line. So once you do that, well, then it becomes just like a proof that we did in the last on the last slide, in that we want to get these two triangles congruent. Now, how are we going to do that? Well, we have right angles, so let's see if we can use HL. Well, OX, what we drew, is the hypotenuse of both triangles, and we know it's congruent to itself because it's reflexive. Okay? Well, we need to just get one leg. We either need YX or ZX to be congruent. Well, that just so happens to be what we're trying to prove, so we know we don't have that, but could we say that OY is congruent to OZ? And we could, because all radii are congruent. Okay, so use this information here, use this drawing to help you out in finishing number 3. That will be part of your homework. Also, if you take a look at number 9 on page 159, so it's on the next page, this also will be part of the work you're going to do in class. You have these overlapping triangles, okay? And I gave you the diagram here to show you that, well, we have this PR is congruent to PO, so these two segments, these two small segments are congruent. We're also given that PH is congruent to PM, so this big segment here is congruent to this big segment there. All right, and we're told that RK is perpendicular to HR, so right angle here, and same thing over here. We have JO is perpendicular to PM, so this angle is a right angle. Well, in these two triangles, we have a purple triangle and a yellow triangle. And both of these triangles are right triangles. So we need to try to prove these two right triangles congruent. Well, we can get a side. If you see here, we can get this side and this side congruent by subtraction. Because if the whole piece is congruent and we subtract congruent parts, then the difference is going to be congruent. Well, now we need to try to get the hypotenuse, because that gives us a leg, but we don't have anything for HJ or MK or JK, so we can't use HL. All right, so just because this is a right triangle doesn't mean we're always going to use HL. HL is not going to be used here. Okay, but what do you know? Well, PMH, this big triangle is an isosceles triangle because we have the tick marks right here. We can conclude the arc marks. And so this gives us our final angle in angle side angle. Be sure in your proof that you state that angle HRK is congruent to angle MOJ. Now, why are those two angles congruent? They're right angles, so right angles are congruent. So remember, in HL, we don't need to state that those angles are congruent, but we're not proving these two triangles congruent by HL. We're using ASA, so we have to state that those two angles are congruent. Okay, so once you get the triangles congruent through ASA, then you can just go from there using CPCTC to say RK is congruent to JO. And you're home free. All right, you're going to have some work you're going to do in class. If you want to try a few problems out, your work is going to be on page 158, and it's going to be 1 to 10. You'll have a few other problems, some review problems to wrap up the chapter a little bit, and then chapter 3 will be finished. If you have any questions, let me know.